hydrostatics. Hydro means water. The meaning of hydro means water. Static means at station. No movement. When you are talking about a tank of water or swimming pool, the water inside this tank, there is no movement, are at station, stationary stage. So we learned that the pressure equal gamma H. Guys, during the homework, most of the students just give me numbers. I don't like numbers. I give you a swimming pool, so please, I'm looking for AB. So you have to do your solution like this. Here is the wall AB, and pressure at A equal gamma H. In this case will be 0. Pressure at B equal gamma H, so you have a value. So you have a value here, you have 0. You have this right angle triangle. Your pressure distribution looks like this. This pressure can be converted to an equivalent static force F. This static force at a distance h divided 3. This static force equal 1/2 time this value time this height. So I can figure out the hydrostatic force. I don't like to see only calculations. I have to see your pressure distribution. You have to draw this distribution. If you didn't, I believe I deducted some points from your homework. Okay, so I'm asking to sketch. I'm asking to calculate the water pressure, so you need to sketch the pressure distribution. Also, based on the last week, we learned something called buoyancy. If you have a tank filled with water and you have a body, this body is submerged, so we can expect something here called a buoyant force. This buoyant force equal gamma of this fluid, which is water, time volume of this body. If the buoyant force greater than the weight of this body, we can expect floating. If the buoyant force smaller than the weight of this body, we can expect sinking of the body. So, buoyant force equal gamma water time volume. Volume of the submerged body. The main two topics that we covered last week and the week before. What is the water pressure? And how can we calculate the buoyant force? Today, I will start a new topic. It's talking about hydrodynamic. What is the meaning of hydro? You are talking about water. Dynamic means we have movement. We have flow. So you are talking about something is moving. So it's called hydrodynamics. Water can move in any direction. Water can move in any direction. Particles of water flowing in a conduit travel generally in the same direction. That makes sense. Same direction. If you have a pipe like this and you have water inside this pipe, I believe if this is the direction of flow, all particles of water are moving in the same direction. Generally, the same speed. You are talking about the same speed. Two fundamental parameters are used to describe the motion of water confined to conduit: velocity and discharge. We will cover these two parameters later. But you have to remember, we have two parameters. What is the velocity of any particle? What is the discharge or rate of flow? Velocity describes the rate of a change of position of the water as defined in fundamental mechanics. Discharge or rate of flow, how much? The amount of water passing through an imaginary plane per unit time. This is the meaning of discharge. This is the meaning of velocity. How to calculate discharge? How to measure velocity? We will cover these two parameters later. But you have to remember, velocity, rate change of position. Discharge, amount of water passing through a plane per unit time. Velocity distribution. If you have this pipe and we have flow in this direction, actually this particle of water and this particle and this particle and this particle and this particle, all of them have different velocity. The actual velocity distribution for flow in a circular tube looks like this. Particle at the middle of the pipe has the maximum velocity. Particle in contact with the pipe theoretically has zero velocity. That makes sense? If you would like to get the value of velocity in between, we can use this equation. V, velocity at any distance r, this r is measured from the center line, equal V maximum, maximum velocity, time 1 minus r divided capital R, all of them square. Capital R is the radius of the pipe. Small r is the radius from the center line to the point you are looking for. So r is the distance from the center line to the point. Capital R is the radius for the pipe. V is the velocity. V maximum is the maximum velocity. Okay? So guys, just to give you a hint, if you have a pipe and you have water inside this pipe, believe me, these particles are not moving with a constant velocity. No. The actual distribution of the velocity looks like parabola. That means any particle at the center line of the pipe is moving with maximum velocity. If you are far away from the center of the pipe, the velocity is decreasing. So if we assume this distance small r, this distance is capital R, this value is V maximum, so the velocity at any distance r from the center equal to V maximum time 1 minus r divided r, all of them square. This is the actual distribution of velocity. probably we are not using the actual distribution, we are using average distribution, and we are assuming constant velocity. Anyway, we have an example here. The maximum speed of an incompressible fluid is 10 meter per second. This is the value for V maximum velocity. Entering the 300 millimeter in diameter. This is the diameter. Pipe. What is the speed at a distance 75 millimeter from the center of the pipe? One more time, we have a pipe. This pipe has a diameter equal 300 millimeter. In this pipe, we have flow of water. The actual distribution of velocity looks like a parabola. The maximum velocity here is given. How much? 10 meter per second. The question asked for what is the speed at distance 75 from the center. So from this center, I measured distance r equal 75. Can you tell me what is the velocity here? Okay, the relationship for this velocity distribution, V at any distance equal V maximum time 1 minus small r divide capital R, all of them square. Guys, what is the value of capital R? Capital R is the radius of this pipe. The diameter is given 300. That means the radius will be 150 millimeter. So the velocity at R equal 75 equal V maximum 10 meter per second, 1 minus small r 75, capital R 150, all of them square. So I can figure out the velocity, just a piece of cake. So 75 divided 150, all of them square, times 10 equal 7.5 meter per second. So if you have a water pipe at home and you have a flow of water, so please imagine that the water is flowing in this pipe with a distribution of velocity looks like this parabola. And the maximum velocity at the center line, and when you go back to the edge of this pipe, the velocity is decreasing. Any question? Any question? This is the first point for today. The second point. Any question? If you have any question, let me know. The second question. Yeah, go ahead.
Do we have to convert the millimeters to meters?
No, for one reason, because the unit for R is the same unit for capital R. So I don't care.
Oh,
if you're using here millimeter, please make sure you are using here millimeter. So the unit can cancel each other. So I don't care what is the unit for velocity. This one is meter per second. That's fine. This one will cancel this one, so I don't have any issue.
Yeah, makes sense. Thank you.
Okay, yeah. The second point, we have two different types of flow. If you have hose of water and the water is flowing through this hose, we can expect two types, actually three types of flow, but mainly two types. The first one can be called laminar flow. The second one can be called turbulent flow. If you are in between, we can say a transition flow. Okay, so laminar flow means we have a smooth flow of water. The water is flowing in this hose smoothly. We cannot expect any turbulence. The velocity of flow relatively is low, and water moves in parallel layers with no cross currents. The flow is moving in parallel layers like this. Flow smoothly. This case of flow can be called laminar flow. Looks like this one. Moves smoothly. The velocity relatively is low, and we have parallel layers of flow. We have another type of flow which called turbulent flow. We have high velocity and we have turbulent like this. We don't have uniform or smooth flow. So I believe if the velocity in this hose is small, is slow, we can expect smooth flow. But if the velocity is very high, we can expect this type of flow, which called turbulent flow. You can feel like a vibration or like something wrong with the hose. Okay, so the first part, we have two types of flow, one called laminar flow. What are the features of this flow? The first one, the velocity, the flow is smooth. The second one, velocity is low. The third one, water moves in parallel layers. The second type of flow, which is called turbulent flow, we have two features, very high velocity, and we have pulsating cross current within conduit. Okay, how can I figure out? We have a flow right now. Can I determine this flow is laminar flow or turbulent flow? Yes, we can. How? By using a number or a parameter called Reynold number. Reynold number is just a number. RE is just a number, which is very important. This number is dimensionless. We don't have units for this number. Help to predict what is the flow pattern in different fluid flow situations. What you mean? If the Reynold number smaller than 2100, that means this flow is laminar flow. If this number greater than 10,000, that means the flow is fully turbulent flow. If the value of this number in between 2,100 and 10,000, that means we are in a transition flow. Okay, so Reynold number is very important number, is a dimensionless number used to figure out what is the type of flow, laminar or turbulent or in between transition. Let's see, Reynold number equal this term or this term, V D rho divide mu, or V D divide nu. V is the velocity, rho is the density, D is the diameter, mu is the absolute or dynamic viscosity, nu is the kinematic viscosity, Re is the Reynold number. We have a term here called the critical Reynold number. The meaning of critical Reynold number is defined as the minimum Reynold number at which a flow will turn turbulent. When the flow turn turbulent, at this situation, we can call Reynold number as critical Reynold number. So guys, this term is the velocity, this term is the diameter, this term is the density, this term is the absolute viscosity. Or equal, this term is the velocity, this term is the diameter, this term is the kinematic viscosity. By using these parameters, I can figure out the Reynold number. Once you get the Reynold number, I can tell you what is the type of flow. This topic is one problem in your FE exam. Sometimes the FE exam is asking for Reynold number, okay? Let's do this example. We have example here. The Reynold number, how much? For 1 foot diameter sphere moving through a fluid, specific gravity equal, absolute viscosity equal, at 10 feet per second. One by one. One by one. Guys, specific gravity. What does it mean? Equal 1.22. Specific gravity for any fluid equal gamma for this fluid divide gamma water. I believe your units here is feet and pound. So 1.22 equal gamma fluid divide 62.4 for water. That means the gamma fluid equal how much? 1.22 times 62.4. 76.128 pound per cubic feet. Just for your information, this gamma fluid will be the same value for rho of this fluid equal 76.128 pound per cubic feet. But this pound is pound force, this pound is pound mass. If you would like to convert, I can help you. So gamma equal 76.128 pound force per square feet. We understand that gamma equal rho times G. So gamma 76.128 equal rho times G so your value, this G will be 32.2 feet per square second. This one is pound force per cubic feet. So the final answer rho to be in pound mass, I need here to divide by G, another G. to convert it to pound mass per cubic feet, your value will be the same value, 76.128, because this term will cancel this one. Anyway, so if you are talking about US unit, gamma will be the same value for rho, but different unit. This one is pound force, this one is pound mass. Anyway, this is the first one. The second one, absolute viscosity. Absolute viscosity, which means mu. How much? 0.00122. And the velocity equal 10 feet per second. So Reynold number equal V D rho divide mu. I'm gonna use the first term. V, velocity 10, diameter, how much? 1 feet or 1 foot diameter. So diameter is 1. Rho 76.128 divide mu 0.00122. What is the value of this Reynold number? $624,000. I believe this number is greater than 10,000. So the flow will be fully turbulent flow. It's very easy. So Reynold number, what is the meaning of Reynold number? Is a very important dimensionless number in fluid mechanics, used to help to predict what is the flow pattern in a different flow situation. Reynold number, I can use this equation to find it, or this equation to find it, based on the available information. Based on the Reynold number, I can determine what type of flow do you have, laminar flow or fully turbulent flow, or in between transition. Any question? Guys, do you have any question? If you have any question at any time, let me know. We have another category for types of flow. Sometimes your flow can be called uniform flow. Sometimes can be called non-uniform flow. Uniform flow will happen if you have cross-sectional area of conduit remains constant. If this cross-section of the flow, sometimes you have channel looks like this, or your flow through a pipe looks like this. If the cross-section remain constant, if the cross-section of the flow remain constant, this flow can be called uniform flow. If the cross-section is non-uniform, you have a change in the pipe size, you have a change in the shape of the cross-section. That means we have something called non-uniform flow. Okay? So the first category to define types of flow, we have laminar flow and the turbulent flow. Reynold number can help you to determine which type of flow. The second category, we have uniform flow and we have non-uniform flow based on the cross-section area. If this cross-section is constant, you have uniform. This cross-section is variable, we have non-uniform. Sometimes we have another category. Sometimes your flow can be called steady flow, sometimes unsteady flow. Steady flow, if you have discharge, is constant over the time. Discharge Q is constant over the time. That means the flow is called steady flow. If the discharge change rapidly, we can call it unsteady flow. In this case, if you have unsteady flow, we can expect water hammer. Water hammer is a very bad phenomena, can cause damage to the flowing system. If I open this video to understand what is the meaning of water hammer.
Water hammer is a shock wave transmitted through fluid contained in a piping system. It occurs when fluid in motion is suddenly forced to stop moving and frequently occurs at pump shutdown. We'll be showing the difference between using a swing check valve and a spring-assisted DFT silent check valve. Here you can see the fluid flow upon pump startup. The motion and slamming of the swing check can cause damage to sealing surfaces and fatigue and wear to the hinge pins. When the pump shuts down, it is gravity and reverse flow that close it.
So guys, can you watch this again? We have a valve is opened, so we have flow in the pipe. That's fine.
Motion and slamming of the swing check can cause damage to sealing surfaces and fatigue. And
if you decide to close this valve suddenly, see what will happen on the right hand side.
Wear to the hinge pins. When the pump shuts.
Can you see? This sudden closing will cause here waves of flow. These waves can be called,
it is gravity and reverse flow that closes or slams the
water hammer.
Valve closed.
This water hammer can cause damage, explosion for the pipe system,
resulting in pressure wave build and water hammer,
which is not good.
Water hammer can also damage pipe hangers, instrumentation, and lead to dangerous work environments.
That makes sense? So the meaning of water hammer, for any reason, we have sudden shutdown of the flow, we can expect waves of flow going and returning back. This waves of flow can be called water hammer because we have expect too much pressure on the pipe system that cause damage in some case. This is the case if you have unsteady flow, if you have a rapid change in discharge. Rapid change because you close the valve suddenly. Okay, so based on the Reynold number, I can figure out what type of flow, laminar flow or turbulent flow. Based on the cross-section dimension or area, I can figure out we have uniform flow or non-uniform flow. Based on the discharge value, if you have constant discharge, we have a steady flow. If the discharge rapidly change, we have unsteady flow. Any question? Let's start to talk about continuity equation. But before continuity equation, I need to highlight something. We understand if you have a pipe and we have flow, this flow has a velocity. This velocity can be a number meter per second or a number feet per second. What does it mean? Mathematically, meter per second, for example, 10 meter per second, that means this flow will travel 10 meter every 1 second. This flow will be traveled 10 meter every 1 second. For example, if we have a velocity equal 5 feet per second, that means this flow can be moved 5 feet every 1 second. So if you have a point here, after 1 second, this point will be moved 5 feet. That makes sense? This is the meaning of velocity. And we understand this. We have another phenomena which called discharge. Q. This discharge equal a number cubic meter per second or cubic feet per second. What does it mean? Guys, remember, cubic meter or cubic feet is unit for volume. That means, for example, if you have here 5 cubic meter per second, that means at this location, we can expect a volume of water equal 5 cubic meter will flow every second. So every second, we have flow at this location. This flow, how much? 5 cubic meter. We have a volume of water will pass this location every second. This volume equal 5 meter per second. This is the meaning of discharge. So the meaning of discharge is how much volume will pass a certain location every second or every unit time. That makes sense? So if you have a flow in a pipe, this pipe has a cross-section area, and the flow in this pipe with a velocity v, we have a continuity equation can tell you the discharge equal area of this pipe time v velocity of this flow. So one more time, if you have a pipe, this pipe has a cross-section area A, and the water flow in this pipe with a velocity v, I can say the discharge equal area time v. And this discharge, which equal area time v, is constant. I am sorry. What you mean by constant? I mean, if you have very long pipe, sometimes the diameter of this pipe is here small, sometimes this diameter increased, sometimes decreased, sometimes increased. We have flow for any reason. That means The discharge at this location will be area time V. The discharge at this location, another area time another V. The discharge here will be area time V. The discharge here will be area time V. Because you are talking about one pipe, these discharge or these relationship or these values will be equal. Area 1 times V1 equal area 2 times V2 equal area 3 times V3 equal area 4 times V4. Let me explain it in more details. If you have hose with this diameter, for some reason, this hose has larger diameter. This one is D1, this one is D2. Let me ask you a question. We have a velocity here, V1. We have another velocity here, V2. Anybody can tell me when the diameter becomes bigger, do you think the velocity will be bigger or slower? What do you think? Logically.
I think it's slower.
Logically, I believe it will be slower. For one reason, we have to maintain this relationship. Area V at this location must equal area V at this location. Does that make sense? Based on something called continuity equation. Let me explain one more thing. This area is small. Why? Because we have a small diameter. This area is very big because we have larger diameter. We need to maintain this product to be equal this product. So that means velocity here must be bigger and the velocity here must be smaller to get finally and two equal values. So we have here higher velocity, we have here slower velocity. That makes sense. So guys, we have something called continuity equation. Continuity equation means discharge Q can be called flow rate or discharge. The two terms will work. Flow rate or discharge equal area time V. And keep in your mind, this product area time V will be constant through the pipeline. At the first cross section, area 1 V1 must equal area 2 V2 must equal area 3 V3 must equal area 4 V4. Let's start to watch this video and see what's going on.
Challenge yourself for her. Challenge accepted.
Purdue University Global. Affordable online education for driven working adults. Apply now at purdueglobal.edu.
The path of its preceding particle, Pare's principle. The flow of a fluid is streamlined. If every particle of the fluid flows exactly the path of its preceding particle and has the same velocity as that of its preceding particle. Consider a fluid moves through a tube of area of cross-section A1 and A2 respectively. the volume of water entering A1 per second and the volume of water leaving A2 per second. Therefore, mass of liquid entering per second at A1 and mass of liquid leaving per second at A2, assuming there is no loss of fluid in tube at each for ideal fluid, therefore, or AV equals constant. This is the equation of continuity.
So area time V is equal this charge, and this term is constant. I'm gonna stop here. That's enough for today. Next meeting, I'm going to go to do some examples on the continuity equation and do more explanations.